and we want to talk about transistor. Uh, Please go and watch the live class for P-N junction diode that we taught. We actually, it's a pity that we lost the last video. We did a video of that particular video again, and we actually we did it again, and go and watch it. Now today we want to talk about transistor, and we'll be taking it gradually. No, normally what we are doing is introduction to what? To transistor. So now transistor, I just played the network figure today. Transistor is formed by sandwiching what? Transistor is formed by what? Sandwiching P-type or N-type between what? What pair of what? Of opposite type. What is it saying? Now let me make it easy and simple. It means that you can form a transistor by 2p and 1n. That is, you can form a transistor by combining or by joining 2p type semiconductor and 1n type semiconductor. That would have form what we call the PMP. Then you can also form a semiconductor by what? By combining what? Two what? N type and one P type what? Semiconductor. So that's why we say a transistor is formed by sandwiching P or N type semiconductor between what? A pair of what? Opposite what? Type. Between a pair of opposite type. Now, what are the what? When a P and another P combine with N, look at what I want to have here. Let me make it bigger. P and P. And we have another one here. Let's call it what? N, P, N. Now, these are the two types of what? Of transistor that we can have or that we have. We have PNP and we have what? NPN. So that is to say, in trying to form a transistor, you can achieve this by sandwiching what? A P-type semiconductor between a pair of what? Of N-type. You achieve what? Between a pair of what? N-type. That means you are going to what? Achieve this one. But when you sandwich your P-type between what? A pair of what? P-type. We are going to have what? This achieve what pair. So when you sandwich what? This N-type between pair of what? Two P-type, you are going to have a PMP. And when you what? You take an N-type, a P-type and sandwich it what? Sandwiching what? What? A P-type between two what? N-type. We have what they call a transistor of what? NPN type. Now the next thing you are going to have is that what are what the terminals? How many terminals do we have? Now the questions we can always ask in the exam is that how many semiconductors make up a what? Or question that the examiner asks in the exam. What are the how many semiconductors make up a transistor? Is 2. There are 2 semiconductors, a P-type diode that make up a what? A transistor. 2 diodes make up a transistor. Look at the diagram. So now this is what? A diode. This is another diode. This is what PN junction diode. This is PN junction diode. But this is positive, negative, negative, and positive. You check the last video. This is the positive terminal of the what of this diode. This positive terminal. Why is negative terminal? So what we are producing here is what PNP. But if you have a what a diode what like this combined like this. So what we want to have is what negative, positive, positive, and negative. This is what NPN. NPN. Now we can also have it in what in form of symbols. This is in form of two diodes. If I now ask you how many diodes make up a what a transistor, you say what two diodes. Now the next question is how many semiconductor make up a what a transistor? Is three. Here is your 1, 2, 3. 1, 2, 3. That means two P type and what? One N. But yeah, how many two what semiconductor? Two N type and one P type, making three. Now we can have another symbol like this. This is symbolic what? Manner of what? Of drawing the what? This what? PNP and NPA. Now this is what? If an arrow is going out from a what? A what? A particular symbol like this. That means you have an arrow going out from the P type, from the emitter. I want to talk about the three terminals. This is the emitter, this is the base, and this is what collector. So that is to say we are talking about three terminals now. That means the diode also have three terminals. I'm coming there, but I will show you something there. Now, if this one, let's take this one as E, B, and C. Now, when arrow is going out from E, which is what emitter, when we talk about it, is what PNP. But when the arrow is going towards what P, towards E, we have it as what the NPN. So that is this is the base, this is emitter, and this collector. So this is a symbol for what PNP, and this one is NPN. But I just mentioned E. Now, what is E? E is what we call the emitter. What about what C? C is what we call the collector. And what is B? B is called the base. So in the what exam now, they can ask how many terminals make up a what? That how many terminals does the transistor have? They have three terminals: the emitter, the base, and the collector, or the emitter, the collector, and the base. Now, how do you know your work? PNP class listing. Anytime your arrow is look at the arrowhead. Anytime the arrowhead is going away from the emitter, you know that is what PNP. Whenever the arrowhead is going towards the emitter, look at the arrowhead. The arrowhead is going towards the emitter, but whenever the arrowhead is going away from the what emitter, we call it what a PNP. Towards the emitter, NPN. Then in it what two what diode. We have two diodes to make up a transistor, and we have three semiconductors that make up a transistor. Don't forget. What is an emitter? Emitter is the source of an electron. Emitter is source of an electron that is heavily doped. It is heavily doped. It is an outer what terminal of a word. So emitter is what an outer what terminal of a transistor that is heavily what doped, and it is what heavily doped, and it has what is the source, and it is the source of what of electron. Let's take care of that. So now somebody will ask me a question. I say, now don't forget the emitter is forward bias with respect to what? To the base. Emitter is what? Forward what? Biased with what? Respect to the what? To the base. I'm coming, I will explain what I mean by. We have talked about forward bias in the last video. Go and check what the meaning of forward bias in our last video. Then you understand what I mean by a forward bias. Now let's watch. Now, in the what? In when we talk about what emitter, we have talked about the source of what? Of electron. And we have also said this what is an outer terminal of a what transistor that is heavily doped. We have also said that it is forward bias with respect to what? So what is a collector? A collector is a second what? Second what? Outer terminal of the what? Of the transistor, and it is averagely doped. Now, is what? It produces what? It's an acceptor. It accepts what? The majority what? Charge carrier. So it accepts. What about this one? Emitter. What is the difference here? This one, emitter what? Is what? Produce the majority charge carrier. That's how we use the word forward bias here. So why this one what? Accept what? That one produce. Why this one accept what? The majority charge carrier. Now it's what? It is reversed bias with respect to the base. Why the last one, which is the base, I will not talk much on that, is the middle terminal between the what? The emitter and the what? And the collector. So that is to say, the base is the middle terminal between the emitter and the collector. So that means that if you check now, this is the base, this is the what? The emitter, and this is what? The collector. Similarly, the same thing with this one. Now, if you have talked about what? The type of what terminal, we have talked about three terminals of the what? Of the transistor. We have talked about don't forget, this one is slightly doped. This base is slightly doped, and we talked about doping in the first video, semiconductor. Go and watch that and you will understand it. We have also drawn the symbol of what? Of a semiconductor. We have drawn the what? The diode format of representing transistor, and we have also represented the block diagram. I think I've talked about the block diagram of representing what? Transistor, meaning that I've shown you what? That we can have it what? Like this, as PMP block diagram, and we can have what they call what? NPN. So we have thought this one terminal, the other one terminal here, then there's other one terminal here. So making three terminal. Now we have middle terminal, the emitter, the base, and the collector. So we have explained that, and that is clear. Now, after explaining the word, then we have also said that what? That there are three semiconductors that make up the transistor, two diodes make up this transistor. We have represented three terminals what? That what represent what? Or that the diode is made up of. We have represented the symbol. We have explained the word emitter, the collector, and the base. So we say that an emitter is an outer terminal of a transistor that is heavily doped and it is source of what? That means it produces what? Majority charge carrier in the what? In the transistor. That is also forward bias with respect to the base. Collector is the second outer terminal. Look at it, the outer side of it. So the second outer terminal of the transistor, and it is averaging dope. It accepts majority charge what carrier. It is reverse bias with respect to base. We have talked about the base. Now, what are the primary what function of a transistor? What are the primary function of a transistor? Primary function of a transistor. What is it used for primarily? What primarily? It is used for what? For amplification. The primary what? Use of what? Of a transistor. Number one, it is used for what? For amplification. Amplifier, it means to amplify a current means it's what? To control current. It is used what? To control what? The current flow in a circuit. So that means we can use smaller what? Current to what? To produce large current in what? An amplifier. So when what? We say one amplifying a what? A particular what? Circuit, you are trying to control the current there in the circuit. Number two is what? We can use it as a switch. We can use a switch, and you know a switch must have the what? The off and on. Yes, that is what? A switch is used to control the what? The circuit, in order to what? To close and open the circuit, to what? To generate current, and to what? To zero current. To zero the current in the circuit, we can use switch to do that. So a switch is the what? The source of producing, or let me say the what controls whether current flow in circuit or not. For example, if I off my switch, if I off the switch of this source or this light now, everywhere will be dark. But if I on it back, it will come up again. Why will it come up? Because current is already generated, it will continue to flow in that light. And when I off it, it has removed current, it has zero current in the circuit. That is what such switch does. And one thing to explain what application as an application of a transistor and a switch of a transistor. Now we need to know how to bias a transistor. This is second to the last. After this one, we have one more thing to talk about. Then we are done with transistor. Transistor does not have much at this level. Though for A level, where we are going to talk about grade 2, we'll talk about grade 2. That one I will post it normally in the video. But this is grade 1. Transistor is very, very wide. I'm only laying the foundation for now that we need for this level. Now the switch. Now we have talked about application, primary use of the transistor, which is for amplification and for switch. But how do we achieve this in a transistor? Then we need to know how to bias a transistor. In order to explain this, we need to know how to bias a transistor. Now there are 4 ways. There are 4 ways of biasing a transistor. There are 4 ways of biasing a transistor. Let me give you the secret. How many diodes make up a transistor? 2. In a diode, when I thought, go and watch video. How many ways can we bias a diode? 2. How many ways can we bias another diode? 2. 2 plus 2 is what? 4. We can bias a diode in forward and reverse. We take another diode, we can bias it as forward and reverse. That means we now have 2. A diode will produce 2 ways of biasing. Another diode will produce 2 ways of biasing. 2 plus 2 will now give us 4. So that means there are four ways of biasing in what? A transistor. Now let's draw this table so that we can comprehend what I want to say. This table will help us to what? To understand what I want to say. Now, the first thing is what? The biasing. The biasing mode. Now, we have what they call, the first one, we call it as what? Active mode. Active mode is what? One way of biasing a what? A transistor. Number two one, biasing mode is what we call what? The inverted mode. That is number two. Number three of it is what we call the cut-off mode. Cut off. And the last mode is what we call the saturated mode. These are four ways by which you can bias. I will explain how all this mode can come about. Now, what do we need to do? Now, in the normal, this active mode is what we call the normal mode. Please take on that in case you see it on some textbooks like normal mode. Now, in the normal mode, because there are what? Two sides of a transistor. Now, let me draw a what? So that you can see it. Let me draw it like this. That we can see it. Now, we have the what we call the base here. This is the emitter. And this is the collector. Now, if I draw a PMP by making the arrow go out, now there is one side of this side, and there are two sides of the diode now we are seeing. The emitter base and the collector base. Look at the arrow. So we are seeing two sides of the transistor. Now, the emitter base and the collector base. Those are the two sides we are seeing. Now, in the normal mode, the emitter base is forward biased. Forward biased. While the collector base is what? Reversed what? Bias. This is a normal one. That means in the normal mode of a transistor, normally. And this normal mode is what we use for what? For amplification. Please think of that too. So diode is used as an amplification in the normal mode, because in the normal mode, it will now be used to control the current flow in a circuit. The inverted mode is changing this one, bring what? Reversed bias, and this is what? Forward bias. An emitter base can never be reverse bias. Yes, so take note of that. An emitter base can never be reverse bias. And the forward collector base is collector base. Please don't forget. It's emitter base. That means between the what? Base and the what? Emitter. Because normally, terminal of a transistor, when you want to bias them, they will not look as though they are four. Because some of you are seeing 1, 2, 3, 4. It's as though they are four. When you are biasing them, they look like four. But you pin one particular one down. That means you fixed one and talk about the others. So in this case, now the emitter base, and this is what? The collector base. That's what they mean by that. Collector base. So this is start of the emitter base. Normally, collector base is reversed bias for a normal. So when we say somebody is normal, that means you should be seeing with your eye. You know that you be seeing with your nose. It's normal. That is what they call normal mode. Then the cut-off mode is what? Reversed. This one is reverse bias, and this one is reverse bias. Now, in the cut-off mode, the collector current is what? It is zero. The collector current is zero, and the base current is also zero. They asked that question in JAM. Now, the collector current and the base current, they are all equal to zero. Even when you supply with what? high voltage. Why? Because in this particular mode, it is in the off stage of the transistor. Off. Just like when you off a switch. This is the off stage of the transistor. Off. No, a switch can function as both off and on. Off. OFF and on. So this is the off stage. I wrote FOF before. No, I mean OFF. The off stage of the transistor. Then that is because in the reverse stage, don't forget, when a diode is reverse bias, current is minimum, is small. Or we supply what they call reverse saturated current. And that current is very small. In that case, it's more or less like no current we generated. So these are reverse. That means no current in that circuit. Then in the saturated mode, this is forward bias. And this is also what? Forward biased. So that is to say, in the two of them, that this one is in the on mode, on stage of the transistor. The two of them are forward bias. In this case now, the collector current would rapidly increase, even at little what output voltage. So when you supply a little output voltage to this, the collector current rapidly would increase. At this point, collector current and the base current IB and IC is equal to 0. At this point, collector current rapidly increase even with the little output voltage. But at this point of normal mode, everything is normal. The current IE equal to IB plus IC. That is to say, what I'm saying, at normal mode now, when it is normal, normally the base current plus collector current equal to what? Emitter current. Please take note of that. The sum of the base current plus sum of the collector current equals to what? Sum of the emitter current. Anytime you see IE, it means emitter current. Emitter current. IC is what? Collector current. But I don't want to go too much on that. Then IB is what? Base current, because of time. Now, we have also explained everything about what the last part is configuration to end the class. The configuration of the transistor, which I will now still refer to this one. Now, don't forget that at what point can you use a transistor for what? Amplification. At the normal mode. At what mode can the transistor be used? At what? For amplification of what? Of a circuit. We can what? Use it here at normal mode. At what point will a what? A transistor be used as a switch, two modes. The off stage of the transistor and the on stage of the transistor. To off a switch, you have to off it. It must be at the cutoff mode. To on it, it will be at what? The saturated what? Mode. At that saturated mode, the what? Emitter base is forward bias and the collector base is what? Forward bias. At this stage, the collector current, because the collector current is what? Is the output end. This is the output end. This is the input end. So it is the output that determines what is happening in the circuit. So at the output end, the collector current rapidly increase even with little what? Voltage supply. So that is how you know is what? Is in the saturated mode. What about in the cutoff mode? The collector current, the base current is equal to 0. In fact, if collector current and base current equal to 0, that means IC is 0, IB is 0. That means IE will automatically become 0. Because 0 plus 0, I say IB plus IC is equal to IE. Please take note of that. And I've also said, how many ways can we bias a transistor? 4 ways. What are the ways? The active mode region. But this one is not practical mode. So we cannot talk about it. Inverted mode is not really practicable. It is not used in the practical world of transistor. So most of the times, books even neglect, they don't talk about this one. But for essence of what? Theoretical word, essence. That's why I have to bring it in to show you that what? There are 4 modes of a transistor. But these 2 modes or region, cutoff region, is the region where what transistor can be used as switch. These 2. So please take note of that. Very important. Now, what are the configuration of a transistor? How can you configure a transistor? How can you configure a transistor? How can you configure a transistor to work effectively? How can we configure a transistor? Number one is that we can configure a transistor by using the what? By configuration. Let me write it well. Of a transistor. Number one is what? Common emitter configuration. Common emitter configuration. Now, in a common emitter configuration, so does a transistor has anything to do with semiconductor? A semiconductor as a transistor has three semiconductor, three. So three semiconductor, I've said it from the beginning, but three semiconductor make up a what? A transistor. Three semiconductor make up what? A transistor. Please don't forget. Then number two is that a semiconductor, we say the carriers are holes and what? Electron. Then the carriers of what? Of current here are also what? Holes and what? Electron. Don't forget. And majorly what? They what? Deal with current, yeah. Because they are used for what? Application. So they can what? They control what? Everything that happens in the circuit. Control everything that happens in the circuit. So we have common emitter configuration. We have what? Common base. Common base configuration. And we have what? Common collector configuration. Common what? Collector configuration. Don't forget that without semiconductor, you cannot form a what? A transistor. Because what we use, what is N-type? N-type, where did it come from? Where did it originate? It's not for semiconductor. So you cannot even talk about transistor without talking about semiconductor. Because without what talking about N-type and P-type, how can you form a semiconductor? Don't forget there is N-type and P-type that we use to form a semiconductor. When you combine two N-type and one P-type, you form NPN. Then two P and one N, you form PNP. Those are the two types of transistors that we have, and we have drawn it. This one that I draw here is what? PNP, because the arrow is going away from the emitter. Now, let me give you a shortcut of what? Of these three. Let me just give you a shortcut that we don't waste our time on this particular one, because it's very, very wide. Very, very wide. Very, very wide. I would need to clean the board so that we can see clearly. I don't want to show up everything in one place. Now, we have what they call the common what? Emitter. Now, we have the input under it. This is what? Let's write the configuration here. I don't want to go up too much. Then let's write the common emitter. Common base and common collector. Now, what is the what? Output voltage. Or first of all, the input voltage is applied between one terminal and one terminal. Then what is the output voltage? Now, this is what? The three, whatever I want to talk about, the three what? Configuration. Now, in the exam, they will ask you first, what is the output of this configuration? Now, to configure a what? a transistor is to arrange it in a what? To configure is what? To give it an orientation, to give it an arrangement that suits that particular what? Circuit. So in that case, this one now we want to arrange it in a common emitter based on what we want to use it for. Now, the input now here, let me show you something. CEB. Now, these are the three terminals that we have in a transistor. This one can only act as input. Please take note of that. A base is between the what? The collector and the emitter, and can only act as input only. The emitter can only act as input and output. What about this one? It can act as what? Output only. So collector can never be input. It can act as what? Output. Base can act as input only, while emitter can act as what? Input and output. Even in football, we have people that play both strike and midfield. So that's what emitter can do. It can both strike and also come at the middle and play. That means it can both play as input and play as output. Now, when we say common emitter means that what? Emitter is both what is both in the input and the output is fixed. So I fixed this one now. Emitter is fixed. Let me use that local language. If I fix emitter now, what is remaining for us, class? Collector and what? Base. Now, out of these two now, which one can play the role of input now out of the emitter? If I fix the emitter, we now left with one, base and what? Collector. Which one will play the input and which one will play the output? The base. Which one will play the output? The collector. So the output is between the emitter and the base. Then the emitter, the output is what? Emitter and what? The collector. Because emitter is we want to be coming from what both ends, coming out from both ends fixed. Now, what about common base? CB what E? Let me fix the base now. CB, I want to fix the base because common base. When we say something is common in mathematics, it means that is what? Both here in this set and also here in that set. So that means what do you mean by common? That means common means the base is both in the input and in the output. Now, what is the competition between collector and emitter now will not be? Which one can play the input? Collector can never act as input, can only act as what? Output only. So emitter can play the role of input. So we play emitter here. Can play the role of input and output. So we have the base what? Emitter. And we are going to have the output between what again? The base and what? The collector. The collector will not be the main one because after taking this one as input, what will remain is collector. Now, let us fix the collector. Let's fix the collector now. We have one collector to be fixed now. If we fix the collector now, which competition are we now having? We are having competition between emitter and the what? The base. Now, which one will now what? Will not be the output now. The output will not be the what? The output will not be the emitter, while the base will not be what? The base can only act as what? Input. It cannot be the output because it's between the two terminals, or it's between two what? Outer terminal, which is collector and base. So it can only act as what? Input, which is base. So you can call it what? The collector base, between the collector and the base. What will now be the output? The emitter. So we now write it because it's common, collector and emitter. We check the two now. You see that something is common to the two of them, collector and collector. If you want to find the intersection between this one now, you say collector is common. What is the intersection between these two now? Base is common. What is the intersection between this one? Emitter is common. That's how we call it a common emitter configuration. Now, we have to know the what? The input and the output. If you go to past questions, sub question, you see that they will ask you in a common emitter configuration, which of these following is the output of the configuration? The output of the configuration will not be what? You now say A, resistor, B, collector, C, capacitor. The answer is what? The output is collector, the common emitter configuration. Now, don't forget, to end the topic now, don't forget that I want to tell you the uses of what? The common emitter. What is used for? Don't forget, this one is used for what? The current amplification. Can use to amplify current. Power amplification. And we can also use for what? Voltage amplification. The middle one now, the what? Common what? Base configuration now. Common base configuration is the next one. We can use it for what? For matching of impedance. For matching. Matching of what? Impedance. Let me explain what we mean by matching of impedance. We can matching and mismatching of impedance. Now, there's what we call buffer. Buffer. Now, I don't want to go this aspect because it has to do in grade 2. I don't know whether I can leave it now, but let me just try to see how I can explain for you. There's what we call the current gain. You don't just try to see how you can get it. A current gain is simply what? Defined as output current over input current. Output current over input current. What is output current here? The current output is, input is here, IB. Current output here is IC. So the current output in this case now is IC. So IC over I1B is the current gain in this particular common emitter configuration. What about this one? In the common emitter, common base configuration, look at it now. Which one is the output current? IC again. Which one is the input current? IE, this emitter current. So the current gain will now be what? IC over what? IE. Current gain for this one, current gain for this one, for the common collector configuration, the current gain is what? IE. The current gain is what? IE over what? I1B. IE over IB. Let me clean this side. Now, if the current gain for what? Common collector, we write it like the common collector to be what? IE over what? IB. IE over IB. Now, if that is the current gain, now what are we saying? Now, note that IE current is greater than IC and IC is greater than IB. Now, current of the emitter, because now this one is the one producing the majority charge carrier. This one we accept, but you get to this one before this one we accept. So, current of the emitter is greater than current of the collector and greater than current of the base. So, now, anytime you are taking I output, this is output and this is input current. That's what I mean by current gain. Now, the output current is higher than input current. And if output current is higher than input current, that means that the impedance of the what? Of the output, impedance of the emitter is smaller than impedance of what? Smaller than impedance of what? The base. Now, what we call matching is that this one is higher than this one. It's smaller than this one. But the current of this IE is greater than current of IB. Now, we have a lower current in the what? In the input and higher current in the what? Output. But we have the what? Lower impedance in the output. Then we have higher impedance in input. Don't forget, current is inversely proportional to resistance. Impedance is a resistance. So those of you that what I don't believe that you are just hearing impedance for the first time. AC, there is impedance. Now, what we now do, this current, the impedance in the output is small compared to input. Now, electronics, an engineer or an electrical electronics, we now what? Take a what? A buffer and match this thing up. That means it will now raise this thing up. That means to make sure that the lower impedance out will now become a higher impedance to now what? Produce a what? A lower impedance. That means before it was higher impedance. That means for the input it's higher than what? Than the output. But now it now want to produce a what? A very what? Better what? A buffer. It will now what? Raise the output impedance and what? Lower the what? The input impedance. For example, impedance causes noise. Anytime you are singing in church, because when you amplify a voice, you notice that what? The noise will just calm and the voice will come out well. Because the noise has been reduced. Now, don't forget, impedance is the one causing when you try to tune your radio, you hear shh, shh. When you now get to a station, you have a clear signal. The station will not, people that what they are saying in that station will not be clear to people that are listening around or anybody in any location, because impedance has been minimized. You cannot eradicate it. Now, maybe you are in your output production when you are configuring your transistor, you now notice that the noise is too much that even the singer could not hear his or herself. Now, what the engineer will do is what? To match the impedance. If the impedance is low, is high on the what output, you will bring it low. If the impedance is low on the output, you will raise it high. Why is he doing that? It depends on the configuration. It is the configuration that will determine the kind of matching and mismatching that will occur in that what configuration. I cannot talk more than that because there are a lot of things. I want to talk about grade 2. Maybe when I'm talking about grade 2, if you want to learn more, grade 2 is what? Advanced level of transistor. I will talk about it. I will shoot it in my video. But for grade 1, for those of you writing the lower what grade 1 exam like SAT exam or probably a Cambridge exam, or probably are writing what do you call it, JAM exam, WAEC or anything, you can, I think to this level, I believe you are okay with it. You are okay with it. So don't forget that means transistor can be used for amplification of current application, voltage application, and power application. Transistor can be used as a switch. Transistor can be used for buffer. Buffer is what? Trying to match the impedance or mismatch the impedance, or to have a clear and better signal, better voicing. You understand now? It baffles me that some of you see some musicians, I don't want to mention name, you see their voice is very cracked, but when they amplify their voice, come out well. It now be as if their voice is not normal voice. I don't want to cause problem. But I believe some Nigerian musicians, you see them, their voice is cracking when they talk to you normally, but when they enter the studio, it becomes something nice because the voice has been amplified. So application is very nice. It brings the best out of the sound. So that's why in most churches, in most music, they will buy an amplifier. What is an amplifier does? It helps to control the current flow in a circuit. It's very nice. And I believe you are able to enjoy the class. I've talked about everything that you need to know. You understand now? Grade 2, if you want to watch the grade 2, I'll post it in normal playlist where I will talk about. Let's change our mind, please. So please, the grade 2 now, we are going to talk about the amplification of other things. So please take note of that. And again, don't forget to rewatch and watch this video again. I've been able to talk about how transistor can be produced. Produce a transistor by joining 2P and 1N to produce NPN, or 1P one N and two P to produce what? A what? To PMP. We have also talked about what? What are the ways, what are the carriers of what? That carry current in a transistor. Just know that this is what? Holes and electron. And don't forget, there are four ways by which you can bias a transistor. You can bias them in four ways. The active mode, which is responsible for amplification. We have the what? The what? Cutoff mode, which is what? In that case, the current is what? Absolutely what? The collector current is what? Is zero, and as such, you need to what? The base current to be zero. In that case, even when you supply an high voltage to that circuit, current will still be zero because it's in the off stage of the what? Transistor. We have talked about what the saturated mode or saturated region where the current is what? Both the emitter base and the collector base are both forward bias, and in that case the transistor is in the on stage. I believe you have one or two questions to ask. Probably you can ask them 5 minutes. You type your questions. Let's see what we can ask. It's very easy concerning the class. I will do another video to what? Normal videos to what? To solve questions on transistor. Don't forget that there are graphs for what? For the graph of what? Which are what? We have the please tell people about this class on Mondays and Wednesdays. Every Monday and Wednesdays nights rather, we are going to be doing videos, and till March when you are going to write exam, because I know some people are writing exam later. So ask a question so that we can answer you. And please take note of it. All these questions, all this analysis, you can rewatch and watch them over and over again so that you can comprehend better. Because in trying to watch and rewatch, you get better understanding of them. Some of you are just learning this topic for the first time. It is normal that you have some confusion somewhere, or you have a little understanding, you don't have a detailed understanding about one or two things there. Don't forget, by the time you do more, you read or go through those particular video over and over again. Don't be tired of watching it. You see that it will naturally enter your head, and you understand every bit of it. So don't forget to subscribe. And every Wednesday and Friday, we are going to start fluid mechanics. This is the last topic. Go and watch the PN junction that we uploaded a new version of that PN junction because we lost our video, and we did another one concerning that. They say, what is the difference between an alternating current and DC current characteristics of of a transistor? Now you are mixing up everything there. And direct current characteristics of a Now, don't forget that alternating circuit is with sinusoidal circuit. Why direct current is this one is direct current. And the device that converts AC to DC is a rectifier, which I've explained before. But a transistor does not do with um, converting AC to DC. What is that it helps to amplify, it helps to relate, it helps to what? For buffer purposes. You understand? It also helps for what? For switching off and on mode. And I've told you how it can be used for on and on. The way they always ask question most in that type of mode is that cutoff mode. Most of the time, if we check most foreign exams and all that, they will tell you what is the at the cutoff mode. What are the functions or what are the characteristics, the things that happen during the cutoff mode? Now, don't forget that the collector current is zero at the what cutoff mode. As such, the base current is also what? Zero, because in that case, it is acting as a what? A switch. Off switch. So how does the transistor current gain affect its performance in an amplifier circuit? Now, the current gain, a good transistor must have a what? A high current gain. Don't forget, a good transistor must have a high current gain. So somebody say, how can it what? If you want to have a transistor that is what? Good, a good transistor must also have a low linkage current. I will talk about one in grade 2. Those of you that want to watch grade 2, I will post that video before next week. So make sure you always check the video playlist. I will check with those of you that want to know more about transistor. I'm talking about grade 1 now. But the grade 1 can help those of you that writing down WAEC and all that. But grade 2 is for those of you that have Cambridge exam and you want to know more about it. You can watch our playlist. We are going to do more. In fact, grade 2 also is functioning in what is a topic that electrical electronics and engineering student does in what? In university, in Nigerian university, foreign university, South African university, and all that. So grade 2, we are going to talk about. In fact, there are a must to what? Circuit that we can calculate. Just like we have resistance in series, capacitor in series, we have circuit in a what? Transistor. There are calculations we can make or we can do in a what? In a transistor. So somebody asked, how does transistor current gain affect its performance in an amplifier circuit? A high current gain will produce a good what? Transistor. We also have what? A low linkage current. Leakage current can also what? When the leakage current is low, we can have a good what? Transistor. And when you have a good transistor, that means it now function better as an amplifier. That one is A level. So that's why I don't want to talk about current gain too much like that. But I believe that, don't forget, current gain is simply what? Output current over input current. Someone is asking of if there is what? There is calculation in transistor, just that for this level now, we will stop here. Grade 2, there is a circuit. Yes, transistor circuit. And those lessons are in maybe 200 level or grade 2 in a foreign university, they will do what they call, even grade 1 sometimes in other, but university course, we do circuit. We do proper circuit where we use Kirchhoff's word analysis, and we are also using KCL, Kirchhoff current law, and Kirchhoff voltage law to analyze circuit. But for this level, this is introductory part of it, based on the scheme of work that we are working with for this grade 1, for this foundation level. So that is just that. I don't know if anybody has a question, but if you have any question, you can send to our comment section. We are already we need to leave the studio right now because the crew member need to go and rest. I want to appreciate every one of us. Mr. Samuel at the background, my lovely wife, I want to appreciate you for your patience and for the tolerance, for accepting all my wrongdoings and my right doings. Everything you accept, then I want to appreciate you. I want to appreciate our lovely students watching, whether from Nigeria or from abroad, from India, from US, and I want to appreciate every one of you for the love you have for this young man that's standing here. And we believe that we are going to be getting more. We are going to be getting more from us by special grace of God. Thank you very much. God bless you.